So, I'm going to quickly go over how it is that we write an ionic formula. So I have a few examples here. And my first one is sodium bromide. So the first thing you can do is either write the formula or figure out the charges. I'm going to figure out the charges first. So sodium, when I look at my periodic table, sodium is in group 1, so it's going to have a +1 charge. Bromine, I know this says bromide, that's what it's called when it's in a compound. It changes the ending to an IDE when it's a binary compound. Binary meaning 2 elements only. And so bromine is a -1. So now when I write the symbols, I have sodium and bromine. Now, since the formulas, since this is a +1 and this is a -1, they balance out. When we go into a compound or a unit cell, the unit cell, if you remember, is neutral. So we need to get these numbers to be neutral. And so a +1, -1 is neutral. So we're good. Started you off with an easy one. Another thing to keep in mind is we never leave the charges on our final formula. Our final formula is a unit cell. It's neutral. So there should be no charges there. Calcium nitride. So calcium is a +2. It's in group 2. Nitride, remember the IDE ending, is because it's in a compound. And so this is nitrogen. Nitrogen is a -3. So again, I'm going to write my symbols. Notice I'm leaving some space in between. That's intentional. So when we do this, calcium is a +2. Nitrogen is a -3. And so, if I have +2, +2, oops, I'm sorry, let me take that away for a second. If I have +2 -3, that does not equal 0. So I need to play around with things until I can get this to equal 0. So right now, +2 -3 equals -1. So I need more of the positives. So I'm going to add another calcium. Well, then that's going to make this a +1 because I have +4 -3 is +1. So I'm going to add another -3. And so now I have a -2 because 2 + 2 is 4, -3 is 1, -3 is -2. So that's where I'm getting these numbers from. All right, well, -2. Hey, that reminds me of my calcium because I have a +2. So +2, +2, +2. That's a total of +6. -3 -3 is -6, which is going to give me a neutral charge. So what this tells me is that I need 3 calcium, because each calcium is a +2, and I need 2 nitrogen. So when I write my formula, I need 2 calcium and 3 nitrogen. We're going to get rid of my charges, but before I do that, a shortcut to do this, as long as you understand why the calcium needs 2 and the nitrogen needs 3, because we're balancing out the charges, then you can easily just crisscross and drop your signs. The only time this doesn't work is if it is already balanced. So if this were a +2 and a -2, then we wouldn't have to worry about that. So for example, I'm going to add another one here real quick. So for example, if I had calcium oxide. Calcium's a +2, oxygen's a -2. So CaO, since this is a +2 and a -2, we're going to reduce those. So 2 will divide into both of them evenly, making them 1. So it's just going to be CaO, not Ca2O2, just CaO. All right, back at it. Potassium nitrate. So potassium's a +1. And pay attention here. This is not the same as what we just had above. This is nitrate. If it does not end in an IDE, that tells us that it's a polyatomic. And poly means many, atomic meaning atoms. And so nitrate is telling me that I need to look at my common polyatomic ions. This is on the back of your periodic table sheet if you're in my classroom. And so nitrate is actually going to be NO3, and it has a -1 charge. So with this, potassium is a +1, nitrate is a -1, and so it's just going to be KNO3. So I intentionally included this next one here because calcium, as we talked about up above, is a +2. Phosphate is a -3. So when I have phosphate, again, it doesn't end in an IDE, so I'm going to look at my polyatomic sheet. And when I do that, phosphate is PO4. Now, because I have a +2 on calcium, that means my phosphate I will have to have 2 of, and my calcium I will have to have 3 of. So the calcium, that's not a problem. I just put a 3 down there. But my phosphate, if I put a 2 here, that looks like I'm saying I have 1 phosphorus and 42 oxygen. And not only is that ridiculous, but that's not what I have. I have 4 PO4s. So to designate this, just like we do in math class, we're going to put parentheses around it. And so what this means is that in a single compound, I have 3 calciums. So each box is a calcium. So this is my calcium, this is my calcium, and this is my calcium. It'd be a +2, +2, +2. And then I have a phosphate, and so my phosphate is going to be the PO4. So PO4, which was a -3, PO4, which is a -3. Size is not proportional, so don't worry about that. The point is that I'm showing you that I have 2 phosphates. It's the phosphate compounds that I have 2 of. I hope this helps. If it did help, make sure you like the video so I continue to make these. Have a great day.